Hello, my name is Omkar Balekundri, and I am going to present my machine learning project on predictive maintenance for machine failure detection using supervised learning. There are a number of industrial situations where machine malfunctions can bring substantial disruptions of production plants and downtime and raise maintenance costs. Currently, there are lack of existing approaches which often do not have the ability to accurately forecast machine breakdowns before they happen. The traditional maintenance just provides a reactive approach. In other words, it is only after an equipment has failed the maintenance process is initiated. Therefore, predictive maintenance provides a proactive approach with the goal of avoiding equipment failure by using historical data and real-time monitoring to predict when a failure is most likely to occur. The objectives of this project are to obtain a historical records which includes features such as heat dissipation failure, power failure, overstrain failure, tandem failures, the temperatures, rotational speed, torque, tool wear of the machine. Then we'll pre-process the data by handling missing values, conducting feature scaling, and creating new features if necessary. Also, after this, we'll perform exploratory data analysis on the data to identify important features and patterns. We will experiment and optimize machine learning algorithms like the random forest, XGBoost, and the support vector machine. We will run these models on historical data and receive performance metrics like the accuracy, precision, recall, and the F1 score. Then we'll compare the performance of these three models. I have found the dataset for this project from the Kaggle website. It was available in the Playground series competition. It is in a CSV format and it contains the data collected from the machines. I have performed exploratory data analysis on this dataset. The dataset consists of 136,429 records and 14 columns. Each column gives data about various parameters related to the operations of machine and its failures. In this dataset, there are some features which have a diverse scales and units. The features of the numerical type, like the rotational speed, torque, and the tool wear, have very distinct ranges compared to the temperature variables. This scale incompatibility can hinder the model's performance. Therefore, we'll be scaling all the features in a similar range, resulting in improved model performance and more stable training and prediction. We will create two new additional features that provide insights into the machine's performance, like the efficiency, which represents the ratio of torque to the rotational speed, and the temperature interaction, which is the ratio of air temperature to the process temperature. Implementation of these additional features into predictive maintenance models will enable to train the model more effectively. I have created a correlation matrix based on the features. Correlation matrix, we can see that the tool wear failure, heat dissipation failure, the power failure, and the overstrain failure have a positive correlation with respect to the machine failure. I have sorted the correlation coefficient between each feature and the machine failure in an ascending order. Based on the analysis, the following features exhibit the strongest correlation with the machine failure: the torque, tool wear failure, power failure, overstrain failure, heat dissipation failure, efficiency, and the temperature interaction. The dataset is highly unbalanced. The machine failure parameter has 2148 instances of label 1 and 134,281 instances of label 0. We'll be using a sampling technique. This method incorporates both synthetic minority oversampling technique and edited nearest neighbors for a classification, balancing, and rimming of the noisy sample. By using this technique, It allows development of models that get to learn from a balanced distribution of both minority and majority class instances. In this project, we are going to develop three machine learning models for the predictive maintenance model, the support vector machine, XGBoost, and the random forest. In the support vector machine, I have performed several rounds of experimentation and fine-tuning with the SVM model and found that the following parameter configuration gives a good accuracy. The kernel to the linear, the regularization parameter C, I've set it to 0.1, and the kernel coefficient gamma to 1. The training time of this model is 1.2 seconds and it is pretty fast. For the XGBoost model, I have performed grid search and discovered that the following parameters are the best for the training. The maximum depth, which is responsible for setting the maximum depth of the trees in the forest to 3, the learning rate to 0.01, the objective to the binary logistic, evaluation metric, which is a performance measure to be used during training to evaluate the models. I've set it to log loss. Subsample, which regulates the number of training samples utilized to train each tree. I've set this to 0.7 and the column sample by tree to 0.5. The training time of this model was 1.91 seconds and it is pretty fast. In the random forest classifier, I have performed a grid search and found that the following are the best parameters for the training. For the N estimators, which provides the number of trees in the forest, is 500. Maximum depth, which describes the maximum depth of each tree in the forest, is 5. Minimum samples leaf, which indicates the minimum number of samples necessary to be at leaf, is 1. Minimum sample split, which describes the minimum number of samples needed to split the node, is set to 2. The bootstrap, which indicates whether the bootstrap samples are to be taken into consideration during the tree creation, it is set to false. Therefore, the bootstrap samples are not taken into consideration. The training time for this model is pretty high compared to the other two models. The training time is 57 seconds. Visualize the performance of each machine learning model based on the confusion matrix and a classification report. The classification report for the support vector machine on training data indicates that the accuracy is 90% for this model and the precision for class level 0 is 83% and for class 1 it's 100%. You can see that F1 score for class level 0 and class level 1 is pretty good and which indicates that the model is well trained on the training data. Classification report for the support vector machine on validation data indicates that the accuracy achieved by the model is 100% on the validation data. The precision score for class level 0 is 100% and for class 1 level it is 99%. Therefore, in the conclusion, the SVM model for both the training and validation data is showing a good performance. The classification report for the XGBoost model on training data indicates that the model achieved 91% accuracy on the training dataset. The model predicted 85% of all instances correctly as class 0, and the model predicted 100% of all instances correctly as class 1. The F1 score of class level 0 and class level 1 is pretty good, and it indicates that the model is well trained on the dataset. The classification report for the XGBoost model on validation dataset indicates that the model achieved 99% accuracy on the validation dataset. For the class level 0, The precision and F1 score are 100%, which states that the model is performing perfectly on class 0. The classification report for the random forest model on training dataset indicates that the model achieved accuracy of 92% on the training dataset. The precision score for the class level 1 is 95%, which indicates that the model accurately predicted 95% of the instances labeled as class 1. The F1 score for both class level 0 and class level 1 is 92%, which is pretty well. Classification report for the random forest model on validation data indicates that model achieved 94% accuracy. The precision score for class level 1 is 20%, which states that the model has a higher rate of false positives for class level 1. The F1 score for class level 1 is 33%, which states that the model is not performing well on class 1. Conclusion: all three models perform very well on the training data, but they have a different strengths and weaknesses on the validation dataset. The random forest model has the highest recall for the class 1 machine failure, but it struggles with the precision of this class. The SVM model has a good precision for both classes 0 and 1, but it struggles with the recall for the class 1. And the XGBoost model seems to strike a good balance with decent precision and recall for class 1. The choice of model depends on what we value most in our predictions. For instance, do we place a higher value on a high recall rate, which is the ability to accurately detect actual failures? This is my code of the project. These are input libraries. I have imported data in the form of train data. This is the structure of the data set. Uh, this is the overview of the data set. The count, mean, standard deviation, mean and max. I've created new features, efficiency and temperature interaction here. I've scaled the data using standard scalar. I've created correlation matrix. Then I've created a correlation with respect to each feature and the machine failure and sorted it in an ascending order. I have selected the features for training the model. Then I've resampled the data using SMOTE and ENN. Then this is my I've performed grid search for XGBoost and it gave me the best parameters. I used these parameters to train the data model, XGBoost model. It trained in 1.9 seconds. This is a function for plotting the confusion matrix. This is a confusion matrix for the training dataset, and this is a classification. This is the confusion matrix for the validation dataset for the XGBoost, and this is the classification report. This is the model for support vector SVM, and I have trained the dataset. I have trained the model. This is the confusion matrix for SVM for the training dataset. This is a classification report. This is the confusion matrix for the validation dataset. This is the classification report. I have performed a grid search on the random forest classifier. It gave me the best parameters. I have used these parameters here for training the random forest classifier model. Then and this is a classification report for the random forest on the training dataset and the validation dataset. This is a confusion matrix for the training dataset, and this is a confusion matrix for validation dataset. Thank you.